So let's answer this question. Why Postgres?
Why is Postgres so popular?
Yeah, why Postgres? Why did we choose Postgres?
That's a great question. I want to ask you that because it really is. It has taken off, and I just talked to Sam Lambert, who is, of course, like the MySQL guy, and he's like, I don't get why everyone loves Postgres. Y'all released this, I think 6 months ago was like the initial one. It's been GA now for a little bit. I guess, like, what are the biggest surprises from running it for 5 or 6 months now?
It turns out that when you build what people want, you get a lot of people using it.
Tell me about unikernels. I read about unikernels as part of this thing. How do unikernels work?
So instead of having a full like Alpine Linux or something, you keep only the tiniest bits from that operating system that you need to run the application. Alex, what's going on in your world?
Oh, man. Hey, folks, this is Alex, and I'm excited because we have another good database episode for you. We have Søren from Prisma. Prisma has just been like the ORM of choice in the TypeScript world now for a while. So like they've been huge. I've known the Prisma guys for a long time, back when they were GraphQL, like this GraphQL thing. And it's been fun to see their journey. And now they have Prisma Postgres, which is what we spend a lot of time talking about, which is this unikernel-based Postgres offering, super interesting around just like pay-per-use, usage-based billing, fast cold starts, all that sort of thing. So we go into the tech behind that, just what it's like running this company with like two separate things, this Prisma ORM, and then also these like managed services, very critical cloud services. So really interesting conversation with Søren. Great to have him on. As always, if you have any questions, comments, guests that you want on, feel free to reach out to me or to Sean. With that, let's get to the show. Søren, welcome to the show.
Alex, it's good to meet you.
Yeah, absolutely. I'm excited to have you on. You are the CEO at Prisma, which is just like one of those core foundational companies in the sort of JavaScript, TypeScript world, web development type world. So excited to have you on. I remember y'all like way back when you were GraphQL and talking to Johannes then and that stuff. So it's been fun to see your journey over the years now. But I guess like for people that don't know about you or about Prisma, can you just give us an overview of who you are and what Prisma does?
Absolutely. Calling us foundational, I think, is kind. We've been around for 9 years now, which is a long time. So the early days was GraphQL. We built this backend as a service that gave you a database, a GraphQL API that mimicked that database, and some way to run serverless functions. That was 9 years ago, and people really loved that thing. What we found is that our best customers, though, they would build prototypes, and then they would kind of validate the prototype and then go and rebuild it with proper technology. And we're trying to build a business. So that's a problem for us because that means all of the budget, it goes over here without our thing. So we spoke to those people and tried to figure out what was it you liked about GraphQL and could any of that be part of your real thing? And what they all told us was the data abstraction, the way you modeled your data schema and the way you interacted with the database through GraphQL. They liked that part. So that's what we turned into the Prisma ORM. If you have used Prisma, you know that it feels a little bit like GraphQL. You have this tree structure you describe up front. That's your query. Then we go and load all of that data for you. The way you model your data structure looks like a GraphQL schema because that's where we came from.
Yep, absolutely. I remember, I was back at Serverless Inc. back when this was getting started, and I talked to Johannes, and he like showed it to me. And he was like all pumped about all the like the typing, and like you get all these types and stuff like that. And at that point, I was still like not in the typing world, and I was like, okay, like nicer autocomplete in your editor. And now I'm like, now I love TypeScript. I'm like, oh my gosh, yeah, you all were like way ahead of the curve in some of that stuff, in understanding like unifying some of that front and back end typing stuff, and just like how good it was. Yeah.
It was a really interesting time where everybody was doing JavaScript. JavaScript was starting to happen on the server also. And there was this war between Flow and TypeScript, and it wasn't really clear which of them will win. Obviously, there was a lot of momentum behind Flow, and that was kind of tying into the React or the GraphQL thing. But at some point, the scale had tipped enough that we could say, okay, TypeScript is definitely the winner. And also TypeScript just enabled so many cool things. I think we were the first major library to really push the boundaries, use conditional typing, get all of this. You can do arbitrary SQL-like queries with Prisma, and we give you complete type safety of the input and the output. And right now it's beginning to be normal, but 5-6 years ago, it was really new. It was really exciting.
Yep, for sure. I love it. I guess I don't know how you measure all this stuff, but I assume is Prisma like the most popular TypeScript ORM? It's the one I hear about the most for sure, and things like that.
So we've obviously been looking at this very intensely, and it's difficult to get a clear picture of. But the best data we've settled on is just NPM downloads. Everybody can go and look at that. And about 2 years ago, we crossed the line, so we are the dominant TypeScript ORM, and we continue to put distance to the next ones. That's a really nice feeling. Also, we are still the TypeScript ORM that gives you best complete type safety. If you use some of the other ones, they have gaps. They will let you do things where you can get a runtime error instead of a compile time error because they don't do full type safety.
Yep. Okay. Yeah, it's been fun. I love it. It's super powerful to see it. It's been fun to see it grow and all that sort of stuff. And I want to talk about the ORM more, but I wanted to actually start with Prisma Postgres. That's why we sort of connected in the first place. Is just talking about this, which is a new offering that y'all have. So maybe start off and give me the high level pitch on what is Prisma Postgres.
So in my mind, you're the database man. You're the Dynamo man. Is that right? Are you more of a serverless man?
No, I definitely got into it from the serverless world and got into Dynamo sort of accidentally there. And now I just found databases more interesting. So more people I have on, we end up talking about databases. So that's why I'm really excited to talk to you about this sort of stuff. But also I still do a lot of serverless and TypeScript and stuff like that. So I love Prisma for that. But then, yeah, I'm interested in the Postgres aspect here.
I'm interested in databases because the serverless stuff, the compute side is kind of soft. It just works mostly. For a long time, we talked about cold stars and all this stuff, but we've kind of figured out how to work around that. We now have platforms. Cloudflare is amazing. Netlify, of course, amazing. You can just deploy code and it just works. You don't have to worry about it. You can get preview URLs. You can deploy different versions. You don't have to pay for them unless you use them. It's just so freeing compared to where I came from, 10 years ago, where whenever we wanted a new service, it was in AWS. You need to have a load balancer, you need to have an auto-scaling group, and blah, 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 blah. It costs you $500 at least just to have a dev thing running. And it takes you days. Databases are still in that world. Databases are still these fragile things that are expensive, and you babysit them, and you don't just get another one for each of your preview environments. And it shouldn't be like that. So we kind of got dragged into building a hosted Postgres service. For the longest time, we thought our specialty, our advantage was we were deeply embedded in applications. We thought databases are going to be commoditized to some extent. We're going to sit in between them and do something cool by being in the application and working with multiple different databases. It turned out, though, that everybody who is using Prisma or thought they wanted to use Prisma, they also want us to host a database. So we've had this cloud product for 4+ years now. And more than 50% of everybody signing up, they wanted a product that we didn't have. They wanted a hosted database. So at the end, we just had to say, okay, let's do that. Let's build a hosted database. But let's figure out how can we build a hosted database that is better than what is out there? Because we're going to go through this massive effort. It's not something we take lightly. It is now the entire company is focused on this thing, because to build a hosted database that actually works for individuals and at scale, it's a lot of work.
Yeah, that's a hard problem. So you said you talked about the the Prisma Cloud for the last 4 years. Is that Accelerate, or what's the cloud? What's Prisma Cloud?
Accelerate is the primary thing. So it's this proxy and caching system that sits in between your application and your database. The main benefit you get is we do global caching. So we work with the Cloudflare network. If you deploy your application either globally on Cloudflare, or if you have multiple different regions, you can use Accelerate and we will cache data close to your application. That's good if you have a read-heavy application. We also completely solved the serverless relational database mismatch problem, where traditional databases, they really want long-lived connections, and serverless functions really do not understand how to do long-lived connections, especially if you do multiple regions. If you try to set up a super-based database, for example, and have any amount of just reasonable scale from a Lambda function, it just doesn't work because you have these stale connections that are hanging. They stay open in the database. It just falls over and it's difficult to debug. So Accelerate is this proxy. It sits in between. It solves that problem.
Gotcha. Yeah, it's interesting. You talk about that connection limit issue, and that's how I got into Dynamo completely, is because like Dynamo did not have that issue, and so many people were using Dynamo with Lambda, even though it was like hard in so many other aspects. And I was like, well, let's figure out how to use this darn thing if it works for serverless, and like there are trade-offs to that, upsides and downsides for sure. But like it's amazing how long that's been an issue and like still sort of is an issue,
It's still an issue.
Yeah.
For a long time, we were hesitant to solve it because obviously it's such an obvious issue. The industry is just going to solve it. We were looking at reinvent after reinvent after reinvent, and they just never really solved it. AWS has various different things that kind of works and then got deprecated and like as a mess.
Yeah, that's exactly right. Like all these like sort of goofy workarounds that all sort of work or like work in weird configurations. But yeah, it's interesting you say like you expected the market to commoditize this. And in some sense, it feels like Postgres hosting is like the most commoditized thing there is out there. There's like a million service providers for all these different things. But
so let's answer this question. Why Postgres?
Why is Postgres so popular?
Yeah, why Postgres? Why did we choose Postgres?
That's a great question. I want to ask you that because it really is. It has taken off. And, I just talked to Sam Lambert, who is, of course, like the MySQL guy. And he's like, I don't get why everyone loves Postgres, And it's interesting. I don't know. I don't know if it's like something about its open sourceness and its community around it, or something around its sort of, I don't know. I guess you tell me, since I imagine you looked into this, like why is Postgres so popular?
So I have never actually used Postgres in production. I'm not a Postgres fan. My entire philosophy is I want the database to be as simple as possible. I've used Dynamo a lot. I loved it. In fact, we used Dynamo for the initial prototype of GraphQL way back in the day when we had said we had to move to a real relational database. We picked MySQL. Why? Because it's easy to scale. It's easy to operate. It's a simple thing. Postgres 9 years ago was difficult to operate at scale. It's gotten a lot better. It is being improved. But it is still a case that MySQL is more kind of hardened, battle-tested, large scale. And I know Sam talks a lot about this because all of their customers are like big customers. They're customers who spend $250,000 at Aurora and then moving over to Planet Scale.
It's interesting, but
the Postgres.
So, just to aside, there's his display name on Twitter is V. He works for Terso. I can't know his name, but like he's like, hey, what are the biggest Postgres deployments out there? And it's hard to find the truly enormous ones that you see like in the MySQL world. Like, you see terabyte level ones and a couple terabytes and single digit terabytes. But in terms of like the really enormous ones, hey, that's like all MySQL or Dynamo or different Cassandra, things like that.
Because at that scale, you can't really rely on the fancy stuff that the database can do for you. You need to keep it dead simple. And it's worth it to keep it dead simple and invest some engineering hours in working around it. And the benefit Postgres has is it has all this stuff, the huge ecosystem of plugins and things it can do, and it's really cool. And reality is most people live in a world where they can make use of all of that stuff because they don't have multi-terabyte databases that needs to be sharded across 100 servers. It's just not a thing for most people. So when we look at the Prisma ORM user base, we have more than 1 million developers using the Prisma ORM. And when we look at all of those, the telemetry data we collect, we know what databases they connect to. And we can see it is primarily Postgres. We support MySQL, Postgres, MongoDB, Microsoft SQL Server, SQLite. And it's more than 60% is Postgres.
Wow, interesting. Okay. Yep. Interesting. Are you, and then, that's interesting. I think you're right in the sense of like, hey, Postgres works for some of these people because they don't have to worry about the true scaling problems and they can use all these things. It's almost like you all are creating and I'm gonna get more into Prisma Postgres, but you all are creating like the Dynamo, but with all the relational features, right? Like Dynamo works really well for serverless. It's no connection limits, no cold start type things. But Dynamo was built for this scale, so it had to take out all these features that people like from relational databases, and it just happened to work with serverless stuff. And then it's like finally something is coming along and saying this works for serverless stuff, but still like doesn't take away all the things that we like about a relational database.
Yeah. What I really like about Dynamo, I liked it 5-10 years ago. I still like it. Is you pay only for what you use. You pay for the storage you use. You pay for the operations you perform. And if you perform a lot of operations, it'll just scale up. That's really nice. That's what you want from a data store. You want it to just work, and you want to pay for just what you use.
Yep. And the underrated thing I think about Dynamo is like just the forcing you to sort of use an index or like the primary key is like there aren't any surprises down the road when things sort of scale. I've liked that. I wish that there's I can't remember his name. There's a guy that worked at Facebook and now he has a different company, and he tweeted about relational databases, and he was saying it'd be awesome if you could have like almost a strict mode with a relational database where you have to specify the index you're going to use for it, so that you don't have like these sort of like larger scans or things like that, just like so it would like identify those queries that are going to blow up at some point, so I like that aspect of Dynamo as well.
So we are solving this through the traditional way, which is separate tooling. We have the benefit that we are the layer in your application where you interact with the database. So that makes it a little bit easier for us. But we have this optimized tool that looks at all of your queries and will identify bad patterns like this. Right now, it will give you a recommendation, say you should really do this. But we want to do this other thing where you can set policies for the kind of queries you want to support. And a policy could absolutely be only do no table scans, only do index lookup, this kind of thing.
Index, yep. Oh, that's pretty cool. It's cool, like when you really have control of that layer, like when you're right in between the actual application code and the database, where you can see those insights, see what the database is doing, instrument all that stuff, and figure out how can I improve this in certain ways. Yeah, good stuff. So anyway, tell me about Prisma Postgres. Again, we talked about it being like, in one sense, Postgres is like the most commoditized thing on the planet, but in another sense, like this is a very different offering from most things that are out there. So tell me about like how Prisma Postgres works.
Postgres is still stuck in the 90s. So Postgres hosting is stuck in the 90s, right? You need to buy a box and then you pay for that box every month. And it's a very simple mental model. You pay $50, $200 a month, and then you have a server with 4 CPUs and 8 gigabytes of memory or whatever it is. And you can go and look at those metrics and see, are you getting close to the limit? Should you think about upgrading? And it works really well when you're deploying a single application. Maybe you have relatively steady workloads. It does not work so well if you're trying to give all of your developers preview branches. It does not work so well if you are vibe coding in your application every weekend and need databases all over the place. Then you need to do capacity planning for all of these databases. Who wants to do that? That's a mess. So what we wanted is something that is very similar to the Dynamo experience, which is you can create a Dynamo database and you do not pay for it. You put stuff in it, but you pay for that stuff. You query it, you pay for those queries. So there are a few things we are doing to on a technical level to make that possible. We can talk about those, but really that's the goal we set out for ourselves. Okay, we're gonna go and build this database everybody wants us to do. What do we do differently? We want to be able to just create hundreds or thousands of databases, not worry about it, have them scale automatically.
Gotcha. And so those were like the initial goals. Hey, be able to create these databases, create them quickly, scale up and down quickly, and sort of usage-based costing, I would say. Like, hey, true serverless database type stuff, which we sort of like, people have tried in different ways to get partially that, offer some of these things or in different ways, but there's often like some caveats and things like that. So given that, I guess, tell me about the technical things that, like, given those high level goals, like what were the technical things that y'all had to do to make this work?
So there are a few things to talk about. And the first one is the cost structure. a challenge with relational databases and the kind of queries you can do against them is that a query can be really cheap, like a point lookup in an index that returns almost no data, or it can be extremely expensive. It can be
a full table scan, with aggregations or whatever.
It could be many orders of magnitude more expensive than a regular query. So some other hosted databases, they've tried to figure out how to deal with this. Can they have a pricing model that kind of captures that, and maybe you can charge for rows scanned, or the time it takes, or something like that. And the approach we've taken is, let's see if we can reduce our cost by so much that we can just charge a flat fee per query and have that work out. So that's the approach we're taking. We'll have to see how well that actually works in practice. For now, we're happy with the early results. So how do we reduce cost a lot? And the first decision we made was, let's move outside the AWS ecosystem. Because over the last 10 years, servers has gotten just incredibly cheap compared to what it was when AWS started. And AWS has had some cost reductions. They had a lot of cost reductions in the beginning, but the last 5-10 years, not so much. So AWS is actually extremely expensive compared to if you just go and buy and rack your own servers.
Yeah, I totally agree. So then I guess, like, where are you running this?
We are at the moment just renting space in a Colo facility, because we are relatively early scale, and as we scale up, we'll be building this out.
Gotcha. And so are you like you're doing a Colo, you're running all your own stuff in it. You're running, I don't know, Kubernetes on it to like schedule all these little instances, and
there's no Kubernetes.
No Kubernetes. Okay. Tell me about unikernels. I read about unikernels as part of this thing. How do unikernels work? How is it like different than like maybe the container-based vision I have for everything else? What's going on there?
So that's the other decision we made. We want to be able to run millions of databases on a single bare metal server. And how do you do that? Well, you do not have them running in containers managed by Kubernetes. That is simply too slow and too much resource overhead. So what we're doing instead, we are using a modified version of Firecracker to run these micro VMs. And inside a Firecracker micro VM, we run a unikernel. So let's talk a bit about what a unikernel is. Unikernel is an idea that has been around for a long time. I remember looking at it back in university. I never really thought it would actually turn into something real. But then I found this company from Germany, Unicraft, that has made it real. So the idea of a unikernel is that you take an operating system, a single program, you kind of plop them together and you compile that into one unit. So the general idea of like tree shaking an application, you're left with only what you need. And here you do that not just with the application, but also with the operating system beneath. So instead of having a full like Alpine Linux or something, you keep only the tiniest bits from that operating system that you need to run the application.
Yeah. Okay. So you basically have this unikernel that's like the Postgres engine and enough of the, I don't know, IO ring or whatever sort of IO stuff and that stuff that it needs, and everything else is gone. And this is just like the smallest image that, like, how big is that image maybe compared to like, hey, if you were running Postgres within like an Alpine Linux Docker image or something like that?
Postgres is actually pretty difficult to kind of compress. So it uses a more universal image, and I think we're about half the size of what you would think of with an Alpine image. Over time, that can come down. But the more important aspect is that all the stuff that used to be at the operating system layer is overhead, and it's there because you need to have permission checking, user management, file system safety. And when you have a single operating system running, you don't need any of that. So that means Postgres running on this unikernel can access memory, can access the disk directly. It doesn't need to go into the kernel and wait for a bunch of checks and then get the data back. So ordinary IO operations are faster this way.
Interesting. Okay. Did you have to make many changes to Postgres itself to make it compatible with this, or does that like Unicraft type stuff just handle that as part of that compilation step?
That's a Unicraft thing. So Unicraft is an open source system for compiling unikernels essentially. So you can just go download this thing. It's a CLI that'll do that. You can create a unikernel image. You can run it, and all the work they're doing is creating this unikernel operating system that can then be compiled with your application. So all of the compatibility work really is going into that. It is not modifying the Postgres application.
Yeah, gotcha. Okay. And then what about, okay, so let's just talk about this at a bigger level. If I spin up a Prisma Postgres instance, am I going to be on a single instance on this, like in your Colo facility, like, hey, I'm on this instance somewhere, probably with other tenants as well, but like all my unikernels will be going to be there, all my storage on one instance?
We treat individual databases as separate entities. So you create an account with Prisma, you can go and create 100 databases. They'll end up on different bare metal servers. They have no relationship to each other. So one way you can do multi-tenancy is you can say, here's a security boundary, and we're going to spend a lot of resources maintaining that one, and we put all of your resources inside that security boundary. That's not what we do. We treat every single database as an independent entity that is completely isolated from the rest of the world. So when I schedule a database, you schedule a database, they just get tossed into the pool. They live next to each other. And to make that work, of course, we need an ingress routing layer that can find your database. And we're using our existing Accelerate product for that. Accelerate is this proxy that sits in between your application and the database, and it does routing. And now it also routes to Prisma Postgres databases.
Gotcha. Okay, but then the database I have, it'll be on one machine. So like one thing I was worried about is just like, if you're spinning up all these compute instances, what about just like memory buffers and things like that are loading? But different unikernels can share the same memory for a given database. Is that like if I make a query that has to spin up a new unikernel to execute this query, it's not like it has to go to disk for every single read. It can use existing memory buffers for my database instance on that same machine.
So when you have a database, you have only one unikernel image running with that database. So many requests come in, they all go to the same. We can dynamically change the allocated CPU and memory. It's a little tricky with memory in Postgres because it really does not like memory to be changed underneath it without a restart. And we really do not want to wait for Postgres to restart. So we're doing some trickery to make that work. But all of your requests go to a single virtual machine that runs this unikernel.
Yeah. Okay. That's interesting. Okay. What's been your experience, I guess, building on in this Colo facility compared to the public cloud? I know you said the economics are much better, but just like, what has that experience been like? Has that been good? Has it been hard? I guess, what's that been like?
It's not been a challenge at all, really. The biggest issue is a thing you kind of take for granted when you work with AWS is you can just hit their API, get an instance, and it'll be there. We know from experience that if you ask for a lot of them, sometimes they'll say, we're out, please try again a little bit. But if you go and provision your own hardware, well, you need to buy it and put it in there. It takes a while. If you rent servers from someone, they might list them, but then they are not actually there, and they'll be there next week maybe if you ask for it. So just the speed is slower, and that means there's some capacity planning we'll have to do. It's pretty easy for us because we have one kind of workload, that is the Prisma Postgres offering. We're not an enterprise that are doing all kinds of weird internal applications and trying to figure scheduling out. We have one kind of application, one kind of workload, and they kind of behave the same, and we can instrument it really well.
Yep. Has it been hard, I guess, to build the team DNA to have? I mean, now you have you have these hosted offerings, which you've had now for a while, Accelerate and Optimize and things like that. But also, it's like, hey, on one end, you're building a library, a very advanced TypeScript library, which requires like a certain set of skills. And the other one, you're doing a database hosting service. It's like, man, that's a tough thing to like jam together. Has it been hard to build that team in DNA?
It has been really hard and much harder than I anticipated. It was part of our initial strategy when we kind of pivoted from GraphQL to Prisma all these years ago. And I did not anticipate how hard it would be to have these two different streams in a relatively small company that are supposed to support each other, but really also have their own life, right? We want Prisma ORM to continue to be the best ORM. We want it to continue to grow in adoption. So you need to really have full-on dedication to that thing. And also, I need to have this cloud product that really works, can never go down, that ships in a completely different way from the ORM. And I need the ORM to fully support that thing. It's been really difficult to manage. Yes.
Yeah. Interesting. Which has one of those aspects been harder, or is it just like, hey, the sort of integration between those has been the difficult part?
I think the most challenging thing is that they're just two completely different way of working. Where the ORM, it's now a very mature product. We have, I think we found that half of the Fortune 2000 companies are using the Prisma ORM in some capacity. That means we have serious people in serious companies that depend on this thing, so we cannot mess it up. That has been the case for a number of years now. That means we do very very fixed cadence for releases. Every 3 weeks there's a new release. They're all minor releases. You can upgrade with no problem. We'll never break anything. Once or twice a year we'll do a major release. There can be breaking changes. There'll be well documented. There'll be an upgrade guide. And then this cloud product is completely different. It's very new. It's a lot of excited people who are using it. They want new features. They want us to catch up to the missing functionality. They want us to move a little faster. And also, it's a cloud product, so it ships all the time. But also, if you ship a bug, you break stuff right now for people who are using it.
In their data, yes. Like in the most important part, Yeah. So, yeah. Interesting. You mentioned like missing features and stuff. What are the things like, hey, that people are really clamoring for that y'all are working on?
One thing we get asked for a lot is you can connect to Prisma Postgres to accelerate, which you can only do through the Prisma ORM, which is fine for most things. But if you like to use Table Plus to connect to your database, currently you cannot connect to Prisma Postgres because we do not support direct TCP connections. So we're working on that. In addition to the HTTP-based kind of ingress layer through Accelerate, we'll have traditional TCP ingress. And we want that to not be a side thing. It needs to work well. It needs to be a high performance, good uptime.
Again, we talked about how like the Postgres hosting is like a crowded space. Is there like who are the users or use cases or applications that you're like, hey, Prisma Postgres is right for you, or maybe certain ones that are like, hey, maybe not right for you given your set of sort of trade-offs and needs? Like who are you sort of focusing on?
So we want Prisma Postgres to be right for everybody below a certain level. If you're somebody who wouldn't think twice about spending $2,000 or $5,000 a month on Planner Scale, Prisma Postgres is not right for you right now. But if you are somewhere below that, if you have multiple different databases, if you like Postgres, if you are a Prisma user, certainly Prisma Postgres is probably a good option for you. If you're currently using a hosted database where it's annoying that there are these old school kind of fragile things where you would like to just create more of them and only pay for them when you use them, definitely go check out Prisma Postgres.
Yep, absolutely. You mentioned Colo, do you have like one Colo facility? Do you have a couple different ones? What's your plan there?
So that's the other thing people are asking for. Right now we are in 3 locations, US, East, EU, and Asia. We need to be in more places. We need to be in all the places. We are picking these locations strategically to be very close to AWS data centers. An AWS region has multiple availability zones, and there's some network latency between those. The data centers we pick, they are in between these availability zones. So we can usually get latency to an AWS region that is the same or less than between availability zones.
Okay, that was going to be one of my questions too. Is just thinking about, will you see latency like that? Like if you're running an AWS, but it's not crazy. It's like going cross AZ rather than going cross region or something like that.
Yeah, it's not crazy, and there are ways for us to optimize it. AWS has this ability for you to run a fiber pair directly between their locations and these Colo facilities. So when we get a little bit further with this build out, that's what we'll be doing.
Yeah. Okay. You mentioned Cloudflare earlier too. Are you able to see, or maybe just from talking to customers, is it still heavily dominated by AWS, or are you seeing more people running, applications where they're reaching out to a database on Cloudflare or something else?
We see the majority of our traffic from Cloudflare. From AWS. AWS is the majority. And we aren't really sure, but from talking to people, I suspect the majority is from services like the Cell, Netlify, where it's serverless functions. It's some fully managed thing.
Gotcha. Yeah. So it's people that aren't running a lot of infrastructure themselves, using more sort of managed services and things like that. Very cool. Y'all released this, I think 5-6 months ago was like the initial one. It's been GA now for a little bit. I guess, like, what are the biggest surprises from running it for 5 or 6 months now?
It turns out that when you build what people want, you get a lot of people using it. So that's been a really positive surprise. Accelerate is a product we have had out for 2 years before that. Prisma Postgres has been out in GA only 3 months. We launched it 6 months ago in early access, then 3 months ago GA. It already has more customers than Accelerate.
Wow. Okay.
So we're really happy about that. We see the growth numbers are good. We see a lot of people kind of toying with it, playing around, deploying a bunch of apps. That's really cool. But we also see steady state production workloads. So the uptake has been faster than I had expected.
Yep, cool. What about the operational aspects? Has that been, sort of what you expected? Has it been harder, easier, anything like that?
It's been about what I expected, I would say. We're having to build a bunch of tooling to support it. We work with the Unicraft team. They've been phenomenal. If you want to really nerd out with a team that is like deep in the operating system stuff, and get them on. They are a fun bunch. Right now we have this relationship where we have a shared Slack channel. They help us with a bunch of things. Their product is very early. So when we need to do new things, it often involves working with them.
Yeah. Okay. And you said it's an open source project, but then there's, some company around it providing support and things like that. Is that?
Yes, that's right.
Okay. Yep. Cool. Do you think we're going to see more unikernel adoption going forward?
So it's a good question. And there are 2 ways to build multi-tenant systems, right? Either you can do it at the system level using containers or micro VMs, potentially using unikernels, or you can build it at the application level. So if you have a traditional SaaS application, that thing handles multi-tenancy at the application level. Some people have done the same thing with Postgres, modified Postgres a little bit and be able to do multi-tenancy in the database. When we were running GraphQL all those years ago on MySQL, we just had a separate schema for each database. And that worked well until we got to like 500,000 or something, and there was some overhead we ran into. But it is really, really powerful to be able to do multi-tenancy on the system level. And doing micro VMs and unikernels just enable you to do that a lot more efficiently. So I think we're going to see a lot more of this. And I think we'll see some large players, maybe even AWS, adopt this.
Interesting. Yeah. That'll be fun. Yeah. The whole Firecracker thing, which you all said you're using sort of a modified way, it's been interesting to see that pick up in different places, like Fly doing some stuff with it and y'all and just different things. And just like, yeah, it's been interesting to see some of those evolutions that are happening. I want to talk about the ORM a little bit. First of all, is it tiring to support like a super popular open source library? First of all, so many needs, can't break anything, but people always want more too. What has that been like to be with a very popular library for a long time that's used for a lot of things? Yeah.
I mean, if you talk to open source maintainers, they are always on the verge of burnout because it's just a thankless thing. We're lucky enough to be a well-funded company doing this thing, so we can hire people, pay them well, work on this thing, and that means we can deal with all of that. It has been difficult for us to kind of adjust the way we operate to where we are in the maturity of the product and of our users. So in the early days, it was really important to move fast, to show that we're doing new features. The same way that Bun is an exciting project now that is always like doing new things, because it's early days, they're trying to capture the attention and imagination of people. We did that in the early days, but then at some point that started to not really work. It started to become counterproductive. People want the opposite. They want the stability. So transitioning the way we operate and accepting that some of your early users who liked you for that mentality of just doing stuff and breaking things, they're gonna grumble when you become a little bit more boring and corporate. And that shows up, right? It shows up in social media. It shows up in GitHub issues, and it is exhausting.
Yeah, I know. I'm like, it's a thankless job, or like, you hear good things. People say good things all the time and stuff, but you also like see the grumbling too, and that like sticks with you more. I just remember working on serverless too, and like seeing some of that stuff as well. And it's just like, man, it's hard to be open source like that. Like it's like what Bezos says about like customers being delightfully dissatisfied all the time, no matter what happens. Like they always want more, and it's like fun to do it, but it's also it's tiring for sure. So
yeah, we had a new engineering manager join the ORM team half a year ago, Will, and he put out a manifesto for how we want to be operating. If you go and search for the Prisma ORM manifesto, you will find it, and that has really helped us kind of tune into this new reality we're in. We've gone out and closed just a whole bunch of old issues, of pull requests that we never really got around to reviewing or merging. Just clean things up, and that has made the team more productive.
Yeah. Sometimes you need that where it's like, hey, you're also just like not reiterating the same story in every pull request or issue or things like that. You can tell people, hey, here's our guidelines, and like this sort of fits outside the guidelines. And if you need a different library, you need a different library. But like this is what we're doing, and we think this works for a lot of people. If it doesn't work for you, it doesn't work for you. But just like that clarity, and both for the users, but also for the team of just like understanding what are we prioritizing and things like that. Yeah,
absolutely. And there are also like early decisions made in a library like Prisma that were right at the time, but at some point you realize they're no longer right, and you need to put in the hard work to move on so you can stop thinking about it. And for us, one of those things has come up recently is the fact that we have this Rust query engine. So when we first built Prisma ORM, our idea was, well, TypeScript is clearly a thing. It's being used on the server, but there's also Java and Python and all this other stuff. And eventually we want to go and serve teams and enterprises. There's all this existing stuff they need to maintain. So we need to be able to work with these language ecosystems. So we put all of our work into building the query engine in Rust so that it could be reused in multiple different language ecosystems. For a long time, we had the TypeScript one. The community maintained one for Go, for Python, for other languages. But the reality is nobody really used Prisma in these other language ecosystems. It's like less than 1% of all of our users. And the reason for that is Prisma is awesome. Prisma is cool because it takes advantage of the unique capabilities of TypeScript. TypeScript is just a unique language that way. If you go and look at Java, Python, any other language, they can't do the kind of things that TypeScript can do. So therefore, we can't really provide something that is that much more compelling than existing toolings in those ecosystems. So we made the decision we're going to focus entirely on TypeScript, and that means the decision that follows from that is let's get rid of this Rust thing, because Rust is cool and all, but it's also this 10 megabyte binary you need to download, and it's annoying. It has all kinds of complexity. It's really difficult to contribute to the code. So the team has done heroic work over the last 6 months to kind of take bits and pieces of that, turn it into WASM so we can keep using those, but then rewrite the other stuff in Rust. And I'm really excited for that work. The most recent release last week was the first bit of that.
Interesting. Without the Rust binary?
Yes.
Interesting. Wow, it's close. Yep. So do you have like a timeline you're sort of aiming for cutting a release with that where that is the default?
Yes, but not a public timeline. So like this year. That's what I know.
Yeah, for sure. Oh man, yeah. Was that part of the ORM manifesto? Is just like, hey, we're TypeScript only now. We're getting rid of Rust.
Yep.
Okay, just that clarity.
Let's simplify. Let's get it cleaned up. We really want to get to a point where the community can just contribute functionality in a normal TypeScript code base, and not having to deal with the Rust toolchain and compilations and all this stuff.
Yep. One thing that I thought was interesting, just looking at I was looking at the blog post you put out about that, is like the new query engine is actually faster in most respects, not all of them. There was like one or two that were slower, which is surprising to me because everyone thinks Rust super fast. Is that just because of like the overhead of communication between two processes, or like what's or just like understanding, or like what's driving some of the speed ups there?
It's the serialization and deserialization overhead. The way if you look at a query's lifetime in this old system with the Rust query engine, a query comes in, then gets transformed into its own internal representation. It goes to the query engine. The query engine makes the direct request to the database. That happens in Rust. It gets the data back. The data then has to do a bunch of stuff in Rust, which is fast because Rust is genuinely fast. But then it has to be serialized and put back out to the TypeScript layer. The TypeScript layer does some more stuff and gives it to the application. And that just takes time. So there are a few kinds of queries where that speed up in the Rust query engine is worth it, but most of the time it is not. It's a penalty.
Yeah. Okay. Interesting. That'll be fun. That's exciting to come out. One more thing. I know you all support all these different databases: Postgres, MySQL, SQLite, and Mongo. Does Mongo add a bunch of problems, like not being a relational database, or is it not that hard to do that?
Well, it adds complexity, but it's also not that hard. The way people mostly use Mongo is it looks a little bit like a relational database. And that's the pattern we support within Prisma. You have your tables. You can do relations between the tables. You can follow those relations. And Mongo has gotten pretty good at doing these more relational style queries over the last few years.
Yeah. I always tell people like Mongo is almost a relational database. Like it's got a very smart query planner. It is like totally different. That like it feels weird to group Dynamo and Cassandra with Mongo as NoSQL, because like Mongo is in a separate world, and like given the existence of the query planner, it's a lot closer to Postgres and MySQL, without some of the typing stuff. But yeah,
Mongo is good.
Yeah, it's good stuff. So, all right, cool. Last thing I want to talk about is just like your life as a CEO and some of that stuff. So some business, some of that. I guess like first of all, do you still get to develop very much?
Oh, for quite a while, the team has asked me kindly to not mess with their stuff. But I've also found that it's useful to once in a while just dive in, be with the team, sit down, work for a few days, and when I do that, I try to be a friendly coworker who just follows. So more of a code monkey. I enjoy that. That also helps me understand some of the challenges the team have, suggest things we could improve. And then I do a lot of prototypes. So Prisma Postgres, we built it in a remarkable short amount of time. From the team started to the GA launch was 6 months. I think that's incredible. But I've been thinking about it for a few years. So I built an initial prototype of this thing, not using Unikernels, but using Firecracker, kind of just convincing myself that this could work and would be a good idea. So those are the kind of things I do, where I don't risk destroying stuff that the teams own.
Yeah, for sure. How do you think about AI usage at Prisma? And like, this week or last week, we saw Toby at Shopify saying, hey, you need to be thinking AI first on all of this stuff. Like, how do you sort of think about, given that both the ORM, super technical and deep, like into TypeScript, running a database service, unikernels, like there's not a lot of like prior art for some of those things, to where, hey, if I'm building a B2B SaaS or something like that, that's like, hey, I can honestly generate a lot of this stuff. I guess like
give me some UI screens and
yeah. How do you think about
spit out some tailwind?
Yeah, exactly. That's like all I do is like tell it to spit out some tailwind and I'm good to go. How do you think about that? How are your teams thinking about that?
So it's fascinating. As an industry, we're really in this in-between phase right now. It's clear that there is this massive transformation that is going to impact the entire world, and it's happening much faster than any of us expected just a few years ago. But also, it's like not quite there yet, and it's really frustrating. Every few months, I take a day and I try to do some vibe coding, and it feels really good for the first hour, and then it feels really bad because nothing works anymore. But used carefully, Cursor, Windsurf, GitHub Copilot, whatever you want to use, really helpful. The tab completion, I personally use Windsurf and I love it. Just like tap, and it keeps my context in mind. I know I did this thing recently, so maybe I need to do it again. Super helpful. So 3 months ago, we asked all the teams what their kind of attitude towards AI was, and we got mostly lukewarm feedback. And now, 2 weeks ago, we did the same thing, and everybody was kind of excited about it and used it for something. So what we're doing now is we have an AI tooling budget. We just ask people to use whatever they want, put it on the company credit card. If they find something that works well, share it with the team. And I think that's the right approach right now because it's all kind of crappy and it all moves really fast. And there's no reason in having a top-down mandate on the AI tool to use.
Yep. Have you seen any, I don't want to say like increases or just changes in Prisma usage now that like vibe coding has become more popular, given that Prisma is so popular, tons of examples out there. It's like it's a well-typed thing. So, which helps with a lot of this coding and or like vibe coding type stuff. Like, are you seeing any changes in usage there as this continues to take off?
It's difficult because we're this open source library. We don't really get to understand what people are doing with it. We have telemetry that you can opt out of. The telemetry only runs in development, only on your developer machine. And sometimes we can see some patterns that are really interesting, where it really looks like some AI developer tool is using this particular version of Prisma and running those 3 commands in a row. And all of a sudden, there's like a lot of them happening. So that's interesting. But other than that, we don't really know much. We are talking to these AI app building platforms, Bald, Lovable, these kind of platforms, because they have the need that Prisma Postgres is uniquely created to solve, which is just create lots and lots of these applications.
Super cheap databases, usage based, but otherwise not going to be hanging around. Yeah, good stuff there. I know like MCP has been huge, and y'all released some MCP stuff. Like, how are y'all thinking about MCP?
MCP is still early days in my mind, because you need to do this JSON config janky thing to what is that? I think MCP is going to be really cool. Our MCP server enable you to configure Cursor or whatever you're using to just automatically work with Prisma Postgres. So it can go and create databases for you. It can migrate them. You probably need to watch it a little bit so it doesn't destroy everything. But if you're just developing, it's really nice. The big issue is you need to discover this thing. You need to install that thing, and that's just really weird. What you need is a marketplace kind of situation where Cursor will suggest to you that, hey, it looks like you need a Postgres database, so go ahead and use this MCP server. So that's what we're talking to these IDE companies about. And I think that'll happen in the next few months.
Yep. Interesting. Yeah, it's been interesting to see. I haven't done a ton with it because honestly, just like the Prisma CLIs and stuff like that work pretty well to do all this stuff. And or just like all that, it's like, I don't need to be updating records or doing migrations that way when I have the other, the standard ways that have already been optimized to be pretty easy and clear and debuggable. So I'm still a little nervous on MCPs generally. It'll be interesting to see, as we get into this more agentic world, probably going to be useful, but for now, I'm still nervous about them.
Yeah, as a software tooling company, what I'm really excited about is it does seem like we are going to see a tenfold increase in the number of people doing some version of software development. I think that's going to happen over the next few years. The same way when we went from traditional photography to digital photography in computers, people used to have like dark rooms in the basement or something, and very few people bothered with that stuff. But when you could edit family photos on the computer, lots of people became part-time professional photo editors. The software industry is going through that same transition, right? And we don't think about it like that because we're all the nerds in our dark rooms editing the photos right now, and we love this industry. We make a lot of money. We know how everything works. But there's a whole world out there that is right now being enabled to do the same thing without all the janky stuff that we have put up with for the last decades.
Yep. I know it's hard for me to imagine. Like, I totally see what you're saying. It's like, it's hard. The hard thing for me to imagine is like, what is our world going to be like with 100 times as much software? Like, not that, and I'm not at the place where I'm like, oh, we have exactly as much software as we need right now, but just like, what is it going to look like with that much more? It's hard for me to even picture. I think that's like the wild stuff, but I don't want to sound like the guy that in like 1900 that's like, everything that's been invented has already been invented, but yeah, it's just hard for me to picture.
I live in Berlin, Germany. So for once we might get rid of our fax machines. That would be really nice. If you go out there in the real world, you and really look at it, you realize that there's just so much software that is not implemented, is not written, that is missing. People do all this crazy ass stuff, like they use fax machines. What is going on?
Yep. I went to Japan last year and I was talking to some people there and they're like, yeah, a lot of stuff is still faxed. And I'm like, wow, are you serious? Yeah. Or actually my brother-in-law, he works in the medical field and it's amazing how much they fax records back and forth. Even in the world of EMRs, they're still faxing records and then scanning them into the EMR. It's like, why? Yeah.
That is wild.
Yeah.
But that's because software is so complex and so expensive. So there's the demand for software far outpaces the supply of software, and it looks like that's about to change, and that's exciting.
Supply is going to get a lot cheaper, which is good. It'll be fun. It's like kind of just disconcerting because it's like, man, what I've been doing for the last 10 years is totally going to change, but it's also it's a fun time too to see all this happening.
Alex, what's going on in your world?
Oh man. Not too, I've been doing independent consulting now for like 5 years. And it's like changed in different ways. Some like a lot of Dynamo stuff for a while, a lot of teaching and training in that. I still do a lot of that, but also like I miss doing some app development. So I've been doing more app development back into that like the last 2 years, at least half time doing that. So that's fun. It's been fun, playing with, I haven't tried Windsurf, but I've been a Cursor guy for the last 6 to 12 months. And I think that's pretty good. So it's been fun just like doing that. And the thing I like is just like, I'm like traditionally like a back end guy and not very good at front end at all. But now just being able to like do that enough to where it's like, you can do,
it's amazing,
not great,
right?
But like, yeah, you can do like a full stack thing and just like, it's a lot more fun to just be like doing that. So I'm really enjoying that part of it. Like trying to get my kids involved. My oldest kid is 12 and I got 10, 8. Yeah. Like trying to get them thinking about stuff like, hey, let's go build something or things like that. It's hard to find the time, but like just all that sort of stuff. It's a fun time to be a software developer, I think.
Have you tried Bald or Lovable?
I haven't. Have you? Like, I know you talked about them in like integrations and stuff. I guess like give me the pitch for them.
So my wife is a PM, not a software developer. A few years ago, I tried to get her into like TypeScript stuff. That never worked. But she wanted my help to build a web app. I was like, just go use one of those things. So she sat down with Bald, I think, and got really, really far. Could build amazing things. The integration with the database was a little complicated because there was some Superbase and some OAuth flow and like copy credentials or whatever. But other than that, she could just talk to the thing, look at what it did right there in the browser, have it change all kinds of things. Super cool. You should try this with your kids. I think that's the way to go.
I really should. Yeah. I see like the people making like games and stuff like that. I'm like, oh, I should just sit down with the kids and do something like that. Or honestly, like you talked about the apps that your wife wants. My wife has been saying like our kids' school, they have to like listen to all these like video or songs every week, like some recitation type stuff. And she's like, it's so janky. You have to go on my computer and do it. I wish someone would just like make a mobile app that was like so much easier. And she's like, you should do that. And I'm like, yeah, I know. I need to. I'm like, yeah, just give me a week off of this stuff. And yeah, I want to go do that. So I should check out both. That'd be fun to do with the kids. Can you like, I guess, eject, like once you have like a good core, can you eject and get that in your IDE and take it from there? Or is it like always in the Bolt lovable ecosystem, or what's that look like?
You can eject. I think they both connect to GitHub, so you can just take complete control. And at some point you'll want to do that, because it gets really frustrating to try to just yell at the thing and it continues to make. What they always do is like, you've built a relatively sophisticated thing and then you want a new thing and it breaks the old thing. And then you try to fix the old thing and it's just this Jenga tower.
Yep. I've noticed like, it's like, you know, you have some of that software engineering background and you're like, okay, implement this database access pattern. Now implement the endpoint to do it. Now implement the front end code to like access that endpoint. Now implement the front end feature. And if you can like walk it through and make sure each step is fine, rather than just saying like, do this whole thing, because then it just like gets confused. It's going off everywhere. But if you like have the patterns in your application and you like make sure you're going sort of step by step, it's like amazing how much faster it can be for that sort of stuff. So yeah, it's been fun. I've been digging it. So. But Søren, thank you for coming on. This is great. I've been paying attention to Prisma for a while. Like, I think they're a fun company, and yeah, great it's fun to see your journey from GraphQL to Prisma ORM, and now all these hosted services as well. So I guess if people want to find out more about either you or Prisma, where should they go?
So Prisma.io. If you want to talk to me, go to Twitter, send me a DM. I'm always open to talk to people. Don't send me emails. I don't read emails. Go to Twitter. We have an active Discord. We are very active on GitHub. If you go and open a new discussion, there'll be somebody talking to you within an hour probably. Just go build some stuff.
Yep, exactly. That's the way to do it. Well, I think Prisma is well positioned, for this new AI world with some of the history built up and all the type stuff. Like, yeah, it's good stuff. So, hey, Søren, thanks for coming on today, and best of luck going forward.
Thanks for having me, Alex. This has been fun.
Cool.